Hi everyone, my name is Anel Ngwenya. I'm a student at the University of South Africa, UNISA, studying Advanced Diploma in Civil Engineering. Today I will be presenting in Water Resource Management and Engineering WRM 3701 on the project of EPANET. So we start with the introduction. So in our project we need to design the water supply network for the Tsipise local municipality. So just to go through a introduction, a typical bulk water supply network in Southern Africa comprises of obstruction and water treatment works, pumping station, reservoir and pipelines. So to do that, EPANET can be utilized as the software to design and analyze a water supply network. So in this project we design a water supply network for Tsipise local municipality. The supply network is to provide the water to 4 townships in line with its Water Service Development Plan WSDP. Hydraulic principles should be applied to determine the following components: pipe diameter, flow rate, velocity, pumping head available from reservoir. So we design for the Tsipise local municipality, and here is a locality map. As you can see, we have a Nyangwe River, Chikaliho Hill, of which is going to be our water treatment plant, and then we have our townships: township 1, township 3, township 4. Oh yes, that is the end. And then so we will design following the existing general layout. So we have Nyangwe River, here is our layout, and we have our demand center 1, of which refers to the township. I mean, what is the demand for that township? With demand center 1, demand center 2, demand center 3, demand center 4. And as you can see at the beginning, we have Nyangwe River water treatment plant and the bulk storage, and we have reduced levels for each and every our nodes. So to design this, we will use the software called EPANET. So EPANET is a software application used throughout the world to model water distribution system. So it was developed as a tool for understanding the movement and fate of drinking water constituently within a distribution system, and can be used for many different types of applications in distribution system analysis. So today engineers and consultants use EPANET to design and size a new water infrastructure. So EPANET can perform an extended period simulation of the hydraulic and water quality behavior within the pressurized pipe network, which consists of pipe, nodes, pumps, valve, storage, tanks, and reservoir. It can be used to track the flow of water in each pipe, the pressure at each node, the height of the water in each tank, the chemical concentration, the age of the water, and source tracing. So I will take you through how we use our EPANET to design our water network for Tsipise local municipality. So for now I will just take you through the EPANET file and show you how EPANET was used to design the water network system for the Tsipise local municipality. So here we place a node, we add a reservoir here, and then after adding a reservoir we add all the nodes as shown here, following the general layout plan that was given to us, and we added all the reservoir, we use all the nodes, and then our EPANET, when we have done putting all the required information, we run our EPANET and its run was successfully. So what we did in here is that so here are just the labels. So we added pipes. As you can see, we have pipe 1, pipe 2, and then for each and every pipes we added its information. As you can see, for I'm sorry, this thing is on the other screen. I'm sorry, so this was on the other screen. I'm sorry about that. So as you can see that we have followed the general layout plan as given there. So to develop this one, we added the reservoir. As you can see it here and here, we added all the nodes everywhere where the nodes was needed. Demand center 1, demand center 2, so it all that. And then let me just take you through the pipe number 1. So we did have information for pipe 1. So I'm sorry, this one is on the other screen as well. So is pipe 1. So where does pipe 1 start? It starts from node 1. Okay, water treatment plant, and its length is 600 and its diameter was made as 1000. So this was initially made as 300 and then it was increased since the velocity was above 1.5. so this as well, same thing was done with our pumps. We added our pump 1. As you can see here, that is pump 1, and then we added our pump 2, and then we go through our reservoir and we added our source of which is Nyangwe River. Water treatment plant, we added it, and then after we went to patterns. So we added, as you can see, our pattern is given on the project brief: 0.6, 1.4, 0.6, 1.4, 0.6. so it was added. Then after we did our curves, as you can see here, we were given that our flow is 600 and our height is 80. So we added and got the graph. Same thing with curve 2. Same thing was applied in curve 2. Then after we did our controls, simple control, as you can see that our pump, as it was given that on the brief, that it might pump at least 8 hours without pumping, and then stop at 9 and open at 5, and the result saying prove the same. So our pump was closed at 9. So we did all that. Then after every information was there, we ran our Ethernet. Then we checked for pressure, yes. And then in links we checked the velocity at 00 hours. So as you can see that our velocity are less than 1.5 second, because if it was supposed at least to be right here. So of which means our network system will be able to operate. So that goes to an end. Our system can operate for 72 hours, of which is 3 days, as required by Tshipiso local municipality. So this was the end of our project. I thank you.